We will now restructure the wiring design into two diagrams to separate the door circuitry from the battery circuitry. We rename our existing diagram to Power and Courtesy and create a new diagram called Door Locks. We select the objects from the original diagram. Right-click and select Move To. Select the destination diagram and click OK. We copy the driver armrest zone rectangle back to the power diagram. Notice that, in moving the circuitry, we lost wire 3, which is the battery supply line to the door lock circuitry. We need to create another copy of wire 3 in the Power and Courtesy diagram. We double-click wire 3 in the design browser to generate wire 3 in this diagram. Notice the cross-references to the related instance of wire 3 that is in the door locks diagram. We drag one end of the wire so that it makes contact with the splice. Notice the cross-references for wire 3 on both the diagrams. Next, we use the Shift Select from 1 through F on the wires. Right-click the Properties, select the Attributes tab, and we assign a wire CSA of 0.5. For the wire material from the drop-down, we select TWC, and for the wire spec, we select 16/.2. We then close the design and save. Having created the door lock circuitry on its own diagram, we now want to add some multicores. We want to take the wires that are exiting from the door lock switches and group them into multicores. We first select wires B and C and add a multicore. Click on New. Select its graphic style and give it a name, MC1. We then select Add, and the wires B and C now belong to MC1. Likewise, we create another multicore, MC2, and this time we add wires D and E, which traverse to the passenger side. Select both of them and add them to MC2. Notice the wires move from the Conductors folder into the Multicores folder. And also notice on the Graphics area, we now have multicore symbols. Now we change the colors of the wires for the multicore so that they match the colors of the cable we plan to use. Both multicores will use the same type of cable, so the first set of wires will be defined with color G, and the second wires will be color P. We can verify that wire B still retains its harness attribute that we defined earlier. We must also define it for the two new multicore definitions, MC1 and MC2. With this done, we will do a save. We will take a quick look at some wiring reports. There are several reports available. For each of them, the report format is defined by default XSLT style sheets, which you can customize to suit your design needs. Next, we save and close the wiring design. Before we do a harness synchronization, let's take a look at the wiring table and see the information that it gives us. Currently, we don't have part numbers or wire lengths, nor do we have wire spec or wire size information. We start the synchronization and now see that the information is updated and the multicore is also updated with its inner colors.